Practice 2 is casting process in greenstone. The objective is to melt aluminum alloys in a melting pot to understand a process from the scrap to the finished product. We will use aluminum components, and for the equipment we will use melting pot, molds, furnace, and casting tools, and also we will be using safety equipment. For the process, we first threw sand on the floor with water and bentonite and broke apart all the lumps of the sand. Then we prepared the mold A on the sandbox, putting some lime powder, and then we sieved the sand into the sandbox with the half of the mold inside. After that, we put pressure on the sand so it wouldn't fall when it was lifted. We repeated the process for the side B of the mold, and then we take the mold out of the sand. So then we create a path from the side B in order to throw the melting aluminum and create escape holes in order for the gases to.
Then we pour the aluminum into the molds until the material flows through the other side. Then we wait until the aluminum solidifies for about 30 to 40 minutes. And finally, we take out the pies to start analyzing the impurities, defects, and other defects that can occur by the solidification.
Solidification time, we used Bodinov's rule, which is in which time is equal to B times B over A power n, in which B is the mold constant, in this case of the green sand, B is the volume of the casting, A the area of the casting, and n is a constant for solidification processes. In this case we're going to use 2 as the value of n, and we calculated the volume of the casting to be 476 centimeter cubic, and the total area that was in touch with the mold was 260 centimeters cubic. And we investigated the mold constant of the green sand. In this case, we found that it's about 10 minutes over centimeter cubic, centimeter square. And this gave us a result of 33 minutes of solidification time in theory, but in the laboratory practice, the real solidification time was about between 30 and 40 minutes, and this depends on several factors that affect the solidification time, such as the room temperature, the quality of the green sand, and the purity of the metal.
In this practice, we use the molding by green sand. It has some advantage and disadvantage. One of the first ones are that it is used for exact pieces, and it has a low cost. But one of its disadvantage are the brittle of the mold, and it can be used only once. Also, once that we unmold the piece, we could see that it had two types of imperfections. It was gas porosity and cavities. The gas porosity could be avoided by making holes above the piece in order to make ducts for the gas that is expelled. And for the cavity, we can have a constant flux of the melted metal. In this case is aluminum, so it can make the pieces fillet uniform.
The process of degassing is necessary because if the gases stay inside the mold, the final piece could come with a type of defect called gas porosity, which makes the piece looking as if it had a big amount of bubbles. When in our piece we had a little bit of gas porosity. The degassing process is performed by making small holes in the sand mold in between the filling ducts. These degassing holes are made in the male mold or the hard mold, which is the upper mold in where we made the filling ducts.
In this practice of laboratory, I find very interesting the casting process because we could see the process of melting a material. In this case, the aluminum, and in my case, I have the experience to pour the material into the molds.
I found this type of casting really interesting because it is really precise, such as big companies use it to produce specific parts, and it was a good practice.
I think this practice was helpful for us as mechanical engineers in order to learn more about molding by green green sand and apply this in our future projects.
And I think that for a mechanical engineer, it's very important to understand how to use sand casting because the pieces are to be so specific that everyone should know how to use it. So it's important for us to learn this.
Laboratory practice was useful to understand how these processes work, as it is one of the most used processes in the industry for metal casting, and maybe with some better materials the process could be made in a more efficient way.